Hey guys, happy Friday. I hope y'all enjoy y'all's weekend coming up. So hopefully yesterday y'all did good with tables. Today what we're going to do is we're going to look at graphs, okay? So we're going to find the rate of change with graphs. We're also going to talk about the initial value, and I'm going to give it some new words so that way we can write those down. Even though these words you'll see in lesson 9, I want you to be familiar with them and to let you know that these words come and play, through the entire unit 2. We're going to write equations with graphs, and by the end of this video, I want us to be able to compare graphs and equations. So we'll jump on IXL a little bit just to slowly start getting into lesson 7, which is comparing rate of change and initial value with graphs, tables, and equations. But we'll wait for tables to come in on Monday, okay? I am going to give you a little quiz, a little test that I'm going to let y'all do kind of like we did lesson 6 where you were allowed to take it twice. And we'll do that either Monday or Tuesday. So probably Tuesday is what I have as scheduled. So we'll see how this Friday and Monday go. Okay. So let's get started. Make sure that you have your notebook out. So if you do not have your notebook, I want you to get your notebook and something to write with, pen, pencil, something. You don't need a calculator, but if you want a calculator, every day during Unit 2, go ahead and grab your calculator and get it ready, okay? So pause your video and make sure you've got what you need. Awesome. Okay, so let's get started. Now, I apologize for first, second, third, and fourth because you probably remember this board problem from Wednesday, but nobody else has seen it, so I'm going to read it. And what I want you to do in your notebooks is I want you to write an equation for my word problem that I'm going to give you here, okay? The red maple in her study had a starting diameter of 4 inches. The diameter grew at an average rate of 0.3 inches per year. The graph on the right shows the growth rate of the silver maple tree. Which function has the greater rate of change? So this is what our ultimate goal is today, is to be able to compare two different rates of change. But first, I want you to write an equation for the red maple, okay? I'm going to read it again, and I want you to write my equation for my red maple. The red maple in her study had a starting diameter of 4 inches. The diameter grew at an average rate of 0.3 of an inch per year. Pause my video and write your equation, please. Okay, let's see how you did, okay? Hopefully you did really well, because we did practice that last week with word problems and equations. So we're going to start off with our y equals m times x plus b, where our m is what's being multiplied. That is our rate of change. And our b is our initial value. That's going to always be the starting number that we have in our equation. So let's go ahead and erase our m and see if we can find our rate of change. Look, here it is. It says in an average rate. So did you put that 0.3 by your x? Good. And then your b, which is your initial value, that is what you start off with. And it literally says, look, we're starting with a diameter of 4. So double check your equation and see how you did. Hopefully you did really good. Awesome. Okay. So before we look what's behind my graph, let's talk about how these graphs work. So I'm going to skip ahead, and I'm going to bring us to the graph of our red maple. Okay. Let me make this red maple big. So our equation was this. Okay. I want you to, let's just compare and our initial value. So I just want to look at our initial value right here. And I want to see if you can see where the initial value falls on the graph. Can you see it? Do you see the 4 right here? Okay, so my initial value in my equation is also on a specific axis on my graph, which axis does it fall on? Is it the y or the x? Okay, hopefully you realize it's my y-axis. Good, and so I'm going to fast forward just a little bit. Make sure you have your notebooks ready. You have your notebooks ready? Okay, because I want you to, let's see, where do I have it? Okay, I want you to write down in your notebook this right here, okay, where my b is my initial value, but we're going to call it the y-intercept. Do you know why? Guess where it intersects? On the y-axis. So just like yesterday when I showed you the 0, b, it's the same thing. That is my ordered pair on my y-axis. So with my y equals 3.3x plus 4, then my ordered pair is literally 0, 4. So 0, 1, 2, 3, 4. This is where I'm going to intersect on the y. Okay, so pause my video, guys, and if you would write down that your b is also your y-intercept, okay, and it's where it goes through your y, okay, where it goes through your y-axis. Okay, good. So hopefully you wrote that down. Okay, we'll come back to all this other fun stuff. Okay, so my y-intercept is extremely easy to find on a graph. It's where it goes through the y, okay? Last week we talked about the snow falling. Do you remember our snowfall story? And so here's my little snowfall amount. And look where my y-intercept is here. Where's my initial value? Do you see it? Okay, good. Did you see that it's this 2 right here, right? That's where it starts on the y. So your initial value is your y-intercept. It's the same idea that I am Miss Vallejo in school, and at home I'm mom, but I'm still me. So I have a lot of names, and so do these letters, these crazy M and B's, okay? So my initial value is 2. Now we're going to talk about my rate of change. So just like a table, my rate of change is how the rate is changing vertical and horizontal, or the change in my y over the change in my x. Okay, so watch this. I'm going to have the change in y over the change in x. So let's look at this guy for a minute. You ready? And I like to look at my intersections on my graph exactly where they meet up. So like I'm not going to look at this dot. I can, but I don't want to because I want a clear dot in the middle. So then I'm not going to look at this one either, but I'm going to look here, okay? Do you see where they clearly intersect right like that? Yeah, that's the ones I want you focusing on because those are going to be your clear shots of your ratios, okay? In 7th grade, you know, we did the reciprocal and we talked about unit rate. It's exactly the same thing. The only difference is in 8th grade, we also have this B, this initial value, and that can change my my rate of change as far as being proportional. So, okay, so let's look at this. Let's do a green. Just like we do in a table, and like how I showed you how we moved on our table, we're going to move on our y. So watch this. I'm going from 2 to a 5, and then we'll end up going over. So how many am I going up? Let's see. 1, 2, 3. Notice I went up 3, right? Good. Now let's see how many times I go over. 1, 2, 2. So my y, I went up and I went over on my x. I'm going to show you that again. Let's do it to the next one. Let's see if we still get 3 over 2. You ready? I'm going to change. How am I changing on my y? We're going to go up 1, 2, 3. And then how am I changing on my x? I'm going over 1, 2. So here's my rate of change. And I want you to be, so when we get into lesson 9, we're going to have rate of change with lots of fractions. Fractions are so much better when it comes to my rate of change because it gives me a clear up and over. Whereas if I have a whole number, I have to know that it's all whole numbers are going to be over 1. So, but we're going to have lots of practice with this. This is still new. It's okay. It's going to come. It's going to get easier. I promise. I promise. So, okay. I'm going to add 2 more words. So we've already added the y-intercept for our b, but I'm going to use the word slope with my m today. And the reason why I'm going to use slope is because since we're talking about graphing, our slope is going to be the rise and the fall of our line. And so today I'm just introducing the word slope, but you're still going to hear me say rate of change. So pause my video and get these notes in your notebook. Okay, so underneath on the same page, all this is together with slope and rate of change. It's still all the same. I want you to use the word rise over run. And the reason why it's just a lot easier to say rise over run versus the horizontal change over the vertical change over the horizontal change, or the change of y over the change of x. You're going to hear me say all of these. But just plain rise over run helps you visualize going up and going over. And that's going to help us with our slope or our rate of change. Pause my video and get this in your notebooks. Okay, so let's play with some graphs, shall we? Okay, so in this graph, I want to find out what is my rate of change or what is my slope. So let's see if we can figure this out. Okay, so what I'm going to do first is I'm going to find a clear intersection with my dots. See that? Okay, so now I want to know, how am I going up and over? How am I rising over running? So let's see, how many did I go up? We went up 4, didn't we? So my y goes on top. Now let's see how many I go over. Now be very careful. Look, what goes here? What's in between 0 and 2? Good, 1. So look at that. What's my rate of change? Good, my rate of change is 4. Awesome. Okay, let's try another one. Oh, and before we move on, do we have an initial value on this graph? We don't, do we? If we go through 0, 0, what type of line is that? Proportional. Remember, proportional. So your equation would literally just be 4x. There's no y-intercept or initial value. Okay, let's do another one. Okay, without me, try to find your rate of change or your slope on this graph. Pause my video and see if you can do it without me. Go. Okay, did you pause my video? Let's see how you did. Hopefully you grabbed this point right here because he's clearly right there. Okay, now let's see how I moved on my y. I went to a 6. And then let's see where I went over. Oh, I went to a 3. Did you say your slope or your your rate of change was 2? I hope so. Okay. So what would your equation be? Pause my video and write an equation. Let's see how you did. Did you write y equals 2x? I hope you did. If you did, then you are rocking and rolling, guys. Okay. Don't freak out over this one, but be very careful with your numbers, okay? All right, find me my rate of change or my slope. Pause my video, go. All right, let's see how you did. Did you get 80 over 2, which is 40? Yeah? Okay, if you did, then you're amazing. I'm very proud of you. Good, okay. Let's try this one. So I want you to try 2 things. First, give me your rate of change. Go. Okay, so let's see how you did. Your rate of change. Did you go up 2 over 2? Did you see that 2 over 2 is 1? Okay, next thing I want you to do is I want you to give me my initial value. Where is my initial value? Where is my y-intercept? What number does my line go through on the y? Did you say 1? Sure hope you did. So if my m is 1 and my b is 1, write me an equation. Go. Okay, let's see how you did. How'd you do? Do you know how difficult it is to not be able to talk with you guys face to face? Oh, it's killing me. It really is. Okay, so let's look at Z13 together, okay? I'm going to pull up Z13 on my computer. That way you'll be able to see it with me, and you'll have a better understanding of what we're looking for, okay? So we're comparing the slope and the y-intercept of a graph and an equation. So with this function, we're looking for the rate of change or my slope, okay? So what is the slope of function A? Your slope is your rate of change, which is what? It's 3. Now let's go to that graph and let's see if I can find my slope or my rate of change on my graph. First of all, it starts here, so I have to be very careful. And then I want to see it goes here. Okay, so let's see how my rate of change is on this guy. You ready? So 1, 2, 3, 4 over 1. Well, that would mean function B has a rate of change of 4. So whose function is bigger? So let's see. Function A has a greater slope than function B, or does function A have a less slope? Well, obviously 3 is less than 4, right? So this is how we get, see, is it going to let me? Hey, we did it! Okay, let's try another one. Okay, let's see. So function A, again, we have y equals 3x plus 2, okay, and we are looking at, let me pull this down so I can see what we're looking at. Okay, so we're still looking at slope. All right, so what is my slope on function A? And I want you to tell me what is my slope on function B. Pause my video and figure it out without me first. Go. Okay, let's see how you did. So obviously my m is my 3. Let's see what my m is on this one. So here's my dot, and here's a dot, and I'm going 1, 2, 3, 4 over 1. Well, that's still, let's see, 1. Yeah, that's still 4 over 1. Is this the same equation? It might be the same. But let me just double check it so we can see it. I go up 1, 2, 3, 4. Yeah. So it might have given me the same one. Let's just see. Because it is the same. Okay. So, all right, here we go. We got a different, at least this looks different. Okay, so let's try one more. So we are comparing slopes. And I want to make sure that, let's see if we can make it bigger. Oh, what? There we go. That looks much better. Okay. So find your slope of function A and find your slope of function B. Okay. I wish I could find my drawing tools. And then tell me which one is greater. Pause my video. Okay, let's see how you did. So for function B, again, our slope is 3. And let's see our rate of change for this one. Do you notice that it goes up and over 1, up 1 over 1, up 1 over 1, up 1 over 1? So your slope for this one is literally just 1. So again, the function A is still less than function B. Okay, so this is what this looks like. And so I want y'all to spend just a little time comparing graphs and equations And right now we're, let's do one more. Let's do one more because this one is my y-intercept. Okay, I was waiting for one of these. So your y-intercept is your initial value, okay? Your y-intercept is your b. Got it? Okay. So we're going to look for our b on both sides. So let me see if you can find your b for function A and find your b for function B. Pause my video and see if you could figure out where your y-intercept is. Go. Okay, let's see how you did. Did you notice that's a -2, not a +2? I hope you did, because it's subtraction, so it is a negative. And look where this one goes through. Where does that go through? That goes through 0. So which one is greater? B would definitely be greater, wouldn't it? Because 0 is bigger than -2. So we can safely say that the y-intercept of function A is less. Okay, so what I want you to do from here, this is Z13, so I really want you practicing this one. Again, just get as far as you can. Do not spend, please don't spend like 40, 50, 60 minutes on this. And I'm hoping you'll do really well with Z13 because this is lesson 7. So if y'all do well on this, then we're rocking, and y'all are doing good. There is a quizzes, and I'd rather you do the quizzes. I'm not gonna. It's not that many questions, so do the quizzes first, just to see where you stand, and then do your IXL. So, and then on Monday we'll add in tables to it, okay? And that way we'll compare tables, graphs, and equations and word problems all at the same time. It's awesome. And y'all just hang in there. I miss you guys so much. And just know that I'm doing great. I'm just really tired, but I'm here for y'all, and I'm not giving up. So you're gonna do great. All right, I miss you guys, and I hope to see y'all soon. So bye.